Hello students and welcome back to my channel. Today we are on to the third lecture in sequences. We will be beginning today's lecture discussing about bounded and unbounded sequences. So we begin with the definition of bounded sequences, and if this is your first video, then I would like you to watch the earlier two videos in this, in which we have discussed a number of things beginning with the definition of sequences, the limit and convergence of a sequence, and also the uniqueness of limits and M-tail of a sequence. So let us first start with the real sequence. So let capital X equal to xn be a sequence of real numbers. We say that X is, the first part we will be talking about bounded below and bounded above. So we say that the sequence X is bounded below if there exists a real number small m such that all terms of the sequence are either greater than or equal to m. Secondly, we say that the sequence is bounded above if there exists a real number capital M such that all terms of the sequence xn are either smaller than m or the equal to m. And finally, we say that the sequence x is bounded if it is bounded above as well as below. So we can say that it is bounded if we can find out real number small m and capital M such that small m is less than equal to xn, less than equal to capital M for every natural number n. And lastly, we say that the sequence is unbounded if it is not bounded. Now from part C, we can say that bounded means sequence is bounded above and bounded below. The symbol that I have used for AND is the symbol from logics. Now when we talk about unbounded, so that is we need the negation of this. So the sequence will be unbounded. And by De Morgan's law, we can say that if it is not bounded above, and will change to or not bounded. Let us see an example on this. So we will discuss about the boundedness of the following sequence. The sequence xn, x equal to xn, where xn is given as 2 minus 1 by n square when n is odd, and 3 plus 4 by n cube when n is even. So to discuss about the boundedness, if a sequence is bounded, so our task should be to find out the existence of small m and capital M such that your sequence terms are contained between these two numbers. And in case if you are unable to find out small m or capital M or both, then we say that the sequence is unbounded. Let us see the initial few terms of the sequence. So let us start with x1. So now since it is a conditional sequence, you can say that when n is odd, we are going to map it on minus 1 by n square, while n is even, we are going to map it on 3 plus 4 by n cube. So you need to first see the value of n and then accordingly decide which part of the function we are going to use. So now right now we have n equal to 1, which is an odd number. So we are going to use the first part of the function. So this is going to be 2 minus 1 upon 1 square, which is 2 minus 1, that is 1. Now let me collect the even terms separately. So x2, since n equal to 2 is even, so we are going to take help of this part of the function. So this is 3 plus 4 upon n cube, that will be 2 cube, and that's 3 plus half, so that is going to be 7 by. Then coming to x3, again 3 is an odd number, so we will use the first part and we will have 2 minus 1 upon 3 square, and that is going to be 17 by 9. x4, 4 is an even number, so this is going to be 3 upon 3 plus 4 by 4 cube, 49 by 16. Now if we were to plot a number line and just see the position of these numbers, this just gives us a brief idea. So let's mark x1. So x1 is, let's say this is x1 equal to 1. Now x2 is 7 by 2, so that is exactly 3.5. So we need to go on the right. So let's say this is x2, which is 3.5. Coming to x3, this is slightly under 2. So means x2 is here and x3 is lesser than 2. So x3 is going to be in the middle of x1 and x2. So 17 by, now 49 by 16. So since 16 3 is 48. So this number is slightly bigger than 3. So since it is slightly bigger than 3 and of course it is smaller than 3.5, it is going to be placed between x3 and x2 and x3. So this is x4. So the sequence terms are actually coming between x1 and x2. Now let us see how the entire solution is going to run around. Now after this, what we are going to do is going to be the formal proof or solution of this particular problem, where we are going to discuss the boundedness. So let us start with xn, which is for odd, that is 2 minus 1 by n square. And since you know that 1 by n square is always a positive number and we are subtracting a positive number from 2, so this is going to be smaller than 2. And now we are going to connect it with the even counterpart of the definition of the sequences of the sequence. So since 2 is lesser than 3 and 3 is of course bigger than, 3 is smaller than 3 plus 4 by n. So we have a direct relation between the odd terms of the sequences and the even terms of the sequences for every n. So we have 2 minus 1 by n square is lesser than 3 plus 4 by n. Now let's take into consideration the odd part. So the odd terms of the sequences is given by 2 minus 1 n square, 1 by n square, and while the even part of the sequence is given by 3 plus 4 by n. Now we know that n is a natural number and hence it is going to be greater than equal to 1. So therefore n square must be greater than equal to 1 for every natural number. Now step by step we are going to construct this part of the sequence. So we need the negative reciprocal of n square. So let us first have the reciprocal. So if a number is bigger than or equal to 1, when we take the reciprocal is going to reverse the inequality. And we can say that minus 1 by n square is greater than equal to minus 1. Now just that 2 part is missing. So on the last inequality we are going to add 2 on both the sides. So we'll get 2 minus 1 by n square is greater than equal to 2 minus 1. So on the right we can simplify it to 1. So we'll have that 2 minus 1 by n square is greater than equal to 1. Now similarly let us look over here for the even part of the sequence. We are going to place up similar arguments. We begin with natural number n and hence it is going to be greater than or equal to 1. Since n is greater than equal to 1, now we are looking out for n cube. So n cube is also going to be greater than equal to 1, and hence its reciprocal is going to be lesser than or equal to 1. We need a 4, so we need to multiply both the sides by 4, and multiplication by a positive number doesn't affect the inequality. So we get 4 by n cube is lesser than or equal to 4, and lastly we are going to add 3 on both the sides. So we get 3 plus 4 by n cube is less than or equal to 4 plus 3, that is 3 plus 4 by n cube is less than or equal to 7. So we have these expressions which are going to play an important role to us. Now let us look at the smallest of this. So the smallest of this is 1. So we begin with a chain of inequalities. So we have 1 is less than or equal to 2 minus 1 by n square. Then if you look up to inequality A over here, so 2 minus 1 by n square is lesser than 3 plus 4 by n cube. And in the last part, C, we have got that 3 plus 4 by n cube is lesser than or equal to 7. Thus, the sequence term, all of your sequence term are lying very well between 1 and 7. And this suffices the definition which we had stated. Over here, you can see that all terms of the sequence are greater than or equal to 1. Therefore, your sequence xn is bounded above. Similarly, all terms of the sequence are lesser than or equal to 7. So your sequence xn is bounded above as well, and we can conclude that sequence x equal to xn is a bounded sequence. For the next example, let us take the classic reciprocal sequence. Let me label this as question A, and we'll talk about B now. Let us take x equal to 1 by n. Again, as a matter of practice, we'll just state the initial terms of the sequence so that we get an idea. So the first term is 1, the next is 1 by 2, 1 by 3, 1 by 4, and so on. We begin with n in natural numbers. So we know that since n is a natural number, n will have two conditions over here. N is going to be strictly positive, and n is going to be greater than or equal to 1. Now, if n is positive, we can say 1 by n is also positive. That is, 0 is lesser than 1 by n for every natural number. So you see that 0 serves as the lower bound of the sequence, small m. Moving on to the second part, n greater than or equal to 1. So we will have 1 by n is less than or equal to 1 after taking the reciprocal. And you have the upper bound of the sequence, which is 1. Collecting both the inequalities, we get, therefore, for every n natural, 0 is strictly less than 1 by n, which is less than or equal to 1, and therefore sequence x is a bounded sequence. So that's all from boundedness. Let us move on to the next topic. The next topic we are going to discuss is monotone sequences, that we'll be doing in the next class. Do like the video and subscribe to my channel. Thank you so much. Happy learning.